Good morning, students. Today we will revise exercise 14C, 14D and review exercise. Okay. So in these three exercises, we will discuss how we can find out the volume and surface area of cylinders. Okay. So first I will explain what is a cylinder. So suppose you have a number of coins, okay, and when you put the coins on each other, then you got a shape like this. Okay. So you got two things. First is a circle, okay, and we know the area of circle is pi r square, and after putting the coins on each other we got another factor which is called height. Okay, so volume is equal to circle and a height. Volume is equal to pi r square h. Okay, this is the formula of cylinder. How you can, by using this formula, you can find out the volume of a cylinder. Now how you can find out the surface area? If you open this shape, then you got a figure like this. Okay, this is a rectangle, and we can say this is the circumference of a cylinder, and the upper end is a circle and lower end is also a circle. So area of circle pi r square, again area of circle pi r square, and area of circumference is equal to 2 pi r, and this is height. So what the surface area becomes? Pi r square plus pi r square, or we can say 2 pi r square plus 2 pi r h. Okay, so the surface area of cylinder is 2 pi r square plus 2 pi r h. In this way you can find out the volume and surface area of a cylinder, okay, by using these two formulas. So this is the calculation. In this way you can find out these two formulas. Okay, so now let's come to the queries. I received a query from Dua of exercise 14C, question number 11. Okay, she asked me to explain this question. So let's come to the solution. First, look at the statement of question number 11. The statement is a pipe of diameter 64 millimeters discharges water at a rate of 2.05 millimeter per second into an empty cylinder. Okay, first it was a pipe, and then it discharges water into an empty cylindrical tank of diameter 7.6 centimeter and height 2.3 meters. Find the time required to fill the tank, giving your answer correct to the nearest minutes. Okay, so first we will find out the radius, base radius of pipe. Okay, diameter is given here. We know the formula that radius is equal to diameter divided by 2. So the base radius of the pipe is equal to diameter is given here 64. So we will divide the diameter by 2. 64 divided by 2, in this way we will get 32 millimeters. So since water is discharged to the pipe at a rate of 2.05 millimeter per second, or in other words, in 1 second the volume of water discharged is the volume of water that fills the pipe to a length of 2.05 millimeters. I mean to say that 2.05 millimeter is the height of the cylinder of the pipe. Okay, so in 1 second volume of water discharged, we know the formula of cylinder, volume of cylinder pi r square h. So pi into radius is 32, we just calculated, and 2.05 is the height of the pipe. Okay, so pi r square h, and you will get 2099.2 pi millimeter cube. No need to solve further, because in the last step we can cut pi with pi. Okay, so keep it like this. Now we will find out the base radius of the cylindrical tank. Okay, so how we can find out? The diameter is given here 7.6. So 7.6 divided by 2, in this way we will get 3.8 centimeters. Okay, now the values are given in millimeter, so it's important to convert all the values in the same units. Okay, and I've made this trick for you, that how you can convert. The smallest unit is millimeter, then centimeter, then meter, and then kilometers. Okay, we know that 1 centimeter is equal to 10 millimeters, 1 meter is equal to 100 centimeters, and 1 kilometer is equal to 1000 meters. Okay, again the same thing. This is the smaller unit, smaller unit, and this is the bigger unit. When we move to the smaller unit to the bigger unit, then we divide. Okay, if I want to convert millimeter into centimeter, then I will divide the given value by 10. Okay, and if I want to convert centimeter into millimeter, then I will multiply. This is the from this side bigger to smaller, and from the upper side smaller to the bigger. Okay, so centimeter into meter, we will divide it by 100, the given value, and for converting meter into kilometer, we will divide it by 1000. Okay, and if you want to convert kilometer into meter, then you will multiply similarly all these. Okay, so now we have 3.8 centimeters, and we want to convert centimeters into millimeters. So centimeter is here, and I want to convert centimeter into millimeter. Then what I will do? I will multiply it by 10. Okay, and we also know that 1 centimeter is equal to 10 millimeter, and we are converting from the greater unit to the smaller unit, so we multiply. So 3.8 multiplied by 10 millimeters, and we will get 38 millimeters. Now height of the cylindrical tank is given here as 2.3 meters. Okay, again we will convert 2.3 meters into millimeter. So 2.3 meters, first we will multiply it by 100, and then we will multiply it by 10. Or you can simply multiply it by 1000, okay, for making your calculations easy. So 2.3 multiplied by 100 centimeter, we will get 230 centimeter, and 230 multiplied by 10 millimeters, we will get 2300 millimeters, okay. In this way, you can convert 2.3 meters into 2300 millimeters. So the volume of the cylindrical tank is equal to, again, the formula pi r square h, pi r square into h. Radius is 38 and height is 2300. So after calculating, we will get this value. So time required to fill the tank. Okay, keep in your mind that we are calculating the time. This is the time which is given in seconds. Okay, then we have to convert this time in minutes. So we will divide the volume of pipe divided by volume of cylinder. Okay, or volume of cylinder divided by volume of pipe. In this way, we will get 1582.13 seconds. Okay, and we know that 1 minute is equal to 60 seconds. So for converting this value, the seconds, we divide it by 60. Okay, second is the smaller unit and minute is the bigger unit. So smaller to bigger, we will divide. So in this way, we will get 26 minutes to the nearest minutes. Okay, so this is the time that required to fill the tank in nearest minutes. Okay, so this is question number 11 of exercise 14C.